Here we're going to start graphing quadratic equations. So we should start with the parent graph of quadratic equations, which is going to be y equals x squared. And how do we graph when we don't know how to graph? By picking a whole bunch of points and seeing what happens. So we should pick 0, a couple of positive points, a couple of negative points, and see what their y coordinates are going to be. We plug 0 in, 0 squared is 0, 1 squared is 1, 2 squared is 4. When it comes to the negative ones, negative 1 squared is 1, negative 2 squared is also positive 4. So when we plot these, 0, 0, 1, 1, 2, 4, and on the negative side, you see we get the same thing. At first glance, it kind of looks like that absolute value V shape, but it's really not. It's more of a U shape. So it should have this curve into it. Let me try that again. It's more like it. And this U shape has a special name. It's called a parabola. Some things about it is that it has a lowest point right here. This point is very important to this graph in particular because it is the y-intercept and the x-intercept at the same time, because this is where the graph crosses both of those axes. But because it's the lowest point on this graph, it's called the vertex. Right? Now the vertex, what's special about that is it's really the turnaround point for a parabola. If we look on the left-hand side, the parabola is going down. Then it hits the vertex, turns around, and starts its way back up again. So the vertex is a very important point when it comes to a parabola. And remember, it's a point, so you should write it like a point. The last thing I want to talk about is the axis of symmetry, which we notice that parabolas have this symmetrical nature to them, that if we drew a line right down the middle, the left-hand side is the same as the right-hand side. And it goes back to this part when we look at the table, that whether we picked a positive or a negative number, when we squared it, we ended up with the same y value. And that's why we want to be able to point out the axis of symmetry. Remember, I said that the axis of symmetry was a vertical line that runs through the vertex. Vertical lines have the form x equals, and then the x-coordinate of the vertex is 0. Let's graph another one, and let's think about these important points. So let's find the y-intercept, the x-intercept, the vertex, and the axis of symmetry. Well, to find the y-intercept, we just plug 0 in for the x-coordinate. Well, 0 squared is 0, times 2 is still 0, which means our y-intercept is going to happen at the origin. That's also going to be where our x-intercept is, because in order to find the x-intercept, we plug 0 in for y. So we divide by 2 and square root it, so x is equal to 0. When the x-coordinate, or the x-intercept and the y-intercept are both in the same spot, or when they're both at the when they're in the same spot, it's going to be at the origin, and that is going to be our vertex. The axis of symmetry is going to be that vertical line running through the vertex. So it's going to be this vertical line, x equals 0. But we still don't have our shape. So in order to get a more accurate picture of what's going on here, we should pick some more points and kind of get a better idea. So let's pick 1. If we plug 1 in there, 2 times 1 squared is 2. Which means this point is going to be on our parabola. By symmetry, we could just go on the other side of the vertex, 1 unit, and it'll have the same y-intercept. We can go out to 2. 2 squared is 4. When we double it, we get 8. So that'd be 4, way up top. And that symmetry will hold over here. And what we see is we get this very tall, very skinny parabola. Let's try another one. Y equals x squared plus 2x plus 1. First of all, the y-intercept, that's going to happen when x is equal to 0. So we plug 0 in for x. And we see that obviously the y-intercept is at 1. For the x-intercept, we plug 0 in for y. And we'll solve this by factoring. And so we see that our x-intercept is going to be at -1. When we only have one x-intercept, that's going to be our vertex. So our vertex is going to happen at this point, -1, 0. And the axis of symmetry is going to be that vertical line passing through our vertex. So x equals that x-coordinate, -1. We still only have 2 points. So to finish off our curve, we can use symmetry to help us out. We knew that at 0, the y-coordinate was 1. So if I go just as far on the other side, so that, this is 1 unit away to the right, let's go just as far to the left of our vertex. That would put us at -2. By symmetry, that means that its y-coordinate is also going to be at 1 as well. And we'll start to get a parabola that looks like this. If we want more points, pick more points. So pick 1 and plug it in. 1 squared plus 2 times 1 plus 1, that's going to be 4. And if we go 2 units to the left of our vertex, that'll give us an x-coordinate that's -3, but it would be the same y-coordinate because of that symmetry. We start to get a more complete picture of what our parabola would look like. Last one, y equals x squared minus 4x minus 5. Let's find all the important stuff. The y-intercept is going to happen when the x-coordinate is 0. So that'll happen at y equals -5. To find the x-coordinate, we got to set the y to 0 and solve this. So we can factor it into x minus 5, x plus 1. And there's our two x-coordinates at x equals 5 and x equals -1. So we have two x-coordinates, 5 and -1. So we plot them. Here's 5. There's -1. Now we need to find out where our vertex is. And the thing is, because of that property of symmetry, that means our axis of symmetry has to be halfway in between our two x-coordinates. So halfway in between would be about right here. And we can count 3 units to the left, 3 units to the right. Yep, that's where our axis of symmetry is going to be. That's what axis of symmetry is, a vertical line. Right there, x equals 2. We just count it and see it's at x equals 2. We also know that then has to be the x-coordinate of our vertex. So when we want to find out what the vertex is, we can just plug in 2 for x. 2 squared minus 4 times 2 minus 5 gives us 4 minus 8 minus 5, which is -9. So that'll be way down at the bottom. -2, or 2, -9 would be our vertex, and then we have enough to come up with our graph. We could plot one more point just from symmetry. We went 2 spaces to the left of our axis, so we go 2 spaces to the right, and there we got a nice parabola. I want to talk about finding this vertex again. All right. And let's just look at the equation and find the vertex just a second. When we're given an equation like this, we can find the vertex by using a special formula. The x-coordinate of our vertex is going to happen at -b over 2a. So, in this example, our x-coordinate is going to be -b over 2a. The thing is, a is a coefficient of the first term, b is a coefficient of the second term, and c is a coefficient of the third term. So when we're looking at -b over 2a, b is -4, and a is just 1. So we would simplify this into the -4 is +4 over 2, which is 2. That is our x-coordinate of our vertex. Now when we want to find out what the y-coordinate is, once again, we just plug it in. 2 squared minus 4 times 2 minus 5, which is 4 minus 8 minus 5. Or that -9 again. So, the real important thing here to remember is that if we want to find the x-coordinate of our vertex, which is also going to be the axis of symmetry, we can just look at the equation and use negative b over 2a. That will give us the x-coordinate. We plug it in to find the y-coordinate, and our vertex then is going to be 2, negative 9, which is what we found here.